Hello everyone, today group 9 will introduce you guys to some sorting algorithm. In a theory lesson of CS163, Mr. Ting has already taught us some sorting algorithm such as merge sort, quick sort, and counting sort, etc. Today, we will present three other sorting algorithms, which are bubble sort, comb sort, and cocktail sort. First, I will introduce the bubble sort. This is some information about the bubble sort. Among a varieties of sorting algorithm, bubble sort is a simple one since it is very easy to implement. The main idea of it is sorting from the first to the last element and swapping the wrong adjacent element. Since the worst case complexity of bubble sort is O and square, it is usually used to deal with small databases. This is some fun fact about bubble sorting algorithm. First, it is used to refer to a sorting by exchange and exchange sorting, and the term bubble sort was first used by inversion in 1962. I will demonstrate the procedure of bubble sorting algorithm step by step. Here we compare 36 and 43, and we can see that 36 is smaller than 43, so we keep their position. Continue, we will compare 43 and 59, and we can see that 43 is already smaller than 59, so we do nothing and move on. Here we can see that in the pair of 59 and 75, they are already in the correct position, so we move on. Now in the pair of 75 and minus 6, we can see that 75 is larger than minus 6, so they are in the wrong position, so we need to swap them. Alright, now we will move to the next pair. Again, we can see that 75 is larger than 18, so we swap them. And again 75 is larger than minus 83, so we need to swap them before moving on, and again we swap it. Okay, after a loop of bubble sorting, we can see that the number 75 is already in the correct position, which means that it is larger all of the element before it. So in the next loop, we don't need to swap the number 75 anymore, so we can skip them. And in the following slide, we will introduce the step-by-step demonstration and in a faster movement, so pay attention. Okay, so the array has already been sorted, so let's move to another. Okay, so this is the pseudocode of bubble sort. We can see that here we use two loops, is I and j. The loop I will run from the first element to the last element, and the loop j will go from the first element to the n minus I element. Every time we meet a pair of wrong position adjacent element, we need to swap them. And we can see that after a loop of j, the last element will go to the correct position, so in the next loop we don't need to check that element again. Okay, now I will go to some notes about bubble sorting algorithm. Talking about the implementation of bubble sorting algorithm, we can add a flag swap which return true if there is any swap and return false if there isn't. With this flag, we can end the loop sooner if it returns false, which means that at that time the array has been sorted. And the worst time complexity of bubble sort is O(n) squared, and the space complexity of it is O1 in all cases. Talking about the application of bubble sorting algorithm, since the bubble sort has the worst time complexity is O(n) squared, which is very high compared to other kind of sorting algorithm. So it just have a few application. First, it can check whether an array is sorted or not, and it can use to fix one or two small error in an almost sorted array.
Now I will introduce about the cocktail sort. The cocktail sort is also known as a bidirectional bubble sort, shaker sort, and it is an extension of the bubble sort. It is similar to the bubble sort, but in one pass it will travel forward and backward. Therefore, in a pass, it swaps the wrong order elements and move the biggest element to the end and the smallest element to the beginning of the array. Here is an example. Given an array like this, then we will start checking forward, just like what bubble sort does. Here, we meet the first wrong pair of elements, so we will fix them by swap them, and then we will continue checking and swap until we reach the end of the array. We have moved the biggest element to the end. Because of that, we don't need to check it anymore, so we narrow down the range of checking by 1, and then we go backward to do the checking again. So now we reach the start of the array, so we narrow down the range checking by 1 again, because the element is in the right position. And we continue the process until the array is sorted. Coming to the pseudocode, it is quite easy to implement. First of all, just like the bubble sort, we need a variable to check if there is a swap in the pass or not. If not, it means that the array is already sorted, so we stop the procedure sooner. And here is a part when we do checking forward, and here is the checking if there is a swap or not. And here is the part of checking backward, and we continue the process until we finish sorting the array. For the implementation, we have some notes. First, we need to declare two variables named start at the beginning of the array and the variable end at the end of the array. They move to the middle after each loop to narrow down the range of checking, and a variable named flag to check if they are swapped or not. Talking about the time complexity, the best case of the algorithm is O(n). The worst case is O(n) squared, and similar to the average case, it is n squared, O(n) squared. Although it has the same time complexity as a bubble sort, but in generally, it has a slightly better performance. Why? Let's take an example. Let's consider the array A, which has 5 elements, 2, 3, 4, 5, and 1. So to sort this array into ascending form, the bubble sort needs to do 4 passes. In pass 1, it do checking forward, and then it swap the elements 5 and 1, which is in wrong order. And in pass 2, it do checking forward, and then it swap the elements 1 and 4, which is in wrong order. And in pass 3, it do checking forward again, and it swap the elements 1 and 3, and then the last pass is swap the element 1 and 2. So it requires the bubble sort 4 passes to completely sort this array, but it just requires the cocktail sort 1 pass to sort this array. So let's see. So in the past one, the cutter sort do checking tour, and then it swap the element 1 and 5, which is in wrong order, and then it do checking backward. So it can swap the elements 1 and 4, 1 and 3, 1 and 2, so that the array is now sorted just in one pass. So by checking bidirectionally, it do have the cutter sort perform better than the bubble sort in many cases. So that is the example. And as a cocktail shaker sort goes bidirectionally, the range of possible swaps, which is a range tested, will reduce by 2 per pass. It is a double to the bubble sort, thus it reducing the overall running time slightly, but it is still really slow. So it is used to introduce about sorting algorithm and in education and fixing almost sorted array like bubble sort with linear time complexity.
Next, the third algorithm that we will introduce is CumSort. This is also an improved version of bubble sort, which has one more variable called the string factor, which is normally set to 1.3. This string factor will be used to shrink the gap, which we will swap the elements. Thanks to that swapping elements by gap feature of CumSort, it removes more than one inversion count with each swap and therefore performs better than bubble sort. Although its worst case is still order of n square, the average case is faster than bubble sort and even comparable to quick sort in order of n log n. About some of the history of this algorithm. This algorithm was designed by two experts whose name I don't know how to pronounce in the 1980s, and then it was later rediscovered and given the name CumSort by Stephen Lacy and Richard Box in 1991. It is an improvement over bubble sort, just like the way cell sort improved over insertion sort. So let's get into an example for us to have a better image about this sorting method. At first, we will initialize the gap to be the length of the array. In this case, it is 8. And we shrink the gap by a factor of 1.3, which now makes it 6. And then we start doing the first pass through the array, swapping elements 6 cells apart. Comparing 36 and negative 83, you can see that they are in the wrong order, so we will swap them. Next, comparing 43 and 21. 43 is greater than the latter one, so we'll also swap them. So after finishing the first pass, we will shrink the gap again by a factor of 1.3. In this case, 6 will become 4, and the process continues until the gap is 1 and when it is already sorted. Okay, so this is a pseudo implementation for the algorithm. We will declare a gap variable and initialize to the length of the array. This variable will be used to determine the current gap of the swapping elements. Another variable that we will also need is the sorted Boolean variable. This variable will tell us whether the array is sorted or not for us to break out of the algorithm sooner. So while the array is not sorted, we will update the gap and do the forward pass through the array, swapping the ith number and the I plus gap number if they are not in the correct position, while also updating the sorted flag if needed. This process continues on and on until the array is fully sorted. Some notes on the implementation. So there is a flag sorted to end the loop sooner, just like the other two algorithms. About the time complexity, it is order of n squared in the worst case, just like bubble sort, but on average, it is order of n log n, which is comparable to other fast sorting algorithms such as quicksort or merge sort. And another plus is that about the space complexity, it requires no extra space, which is order of 1 in all cases. Moving on, the conclusion. After having introduced the two algorithms, we will try to compare their time complexity in practice. This is the table comparing the speed of the three algorithms with different input size. So, for a better visual representation, we drew a graph for you to look at. Okay, so as you can see, the bubble sort is the slowest one, which is the black line here, is on the top, and it rises very quickly in order of n square. Next is the cocktail sort, which is the blue line here. It is slightly better than the bubble sort, but it is also very slow. And the next one is COMSORT. You can barely see the line here because it is nearly the same as the OX axis. As I've said, on average, COMSORT is very, very fast, and it is comparable to QuickSort.
Hello everyone, next is the quiz of our group. COMSORT is an improved version. I think the correct answer is bubble sort because COMSORT compares two elements at a variable gap from each other in each iteration, unlike bubble sort, where the gap remains one. The gap between two elements being compared shrink by a factor of after every iteration. Because for the most effective sorting, the distance between the two elements should shrink by a factor of 1.3 after iteration according to experiments. So 1.3 is the correct answer. What is the worst-case time complexity of cocktail sort? The worst-case time complexity of cocktail sort is O n square, like Nam already said before. The initial gap between two elements being compared. The initial gap is equal to the number of elements in the array. What is the best case time complexity of cocktail sort? The best case time complexity of cocktail sort is On, like Nam already said before. Auxiliary space used by COMSORT is O1 is the correct answer because COMSORT does not require any additional space. Auxiliary space requirement of cocktail sort is like COMSORT, cocktail sort also does not require additional space, so O1 is the correct answer. What is the best case time complexity of COMSORT? The best case time complexity of COMSORT is On log n, like said before. How many iterations are required to sort the array using bubble sort and cocktail sort, respectively? The number of iterations in bubble sort is n-1, so it is 4, and the cocktail sort do the work like bubble sort, but in two directions, so the number of iterations just equal to half of n-1. Therefore, the correct answer is 4 and 2. The number of iterations required to sort the array using comb sort and bubble sort will be. The number of iterations in bubble sort is n-1, so 85, and the initial gap of comb sort is 6, and it shrinks by a factor of 1/3 in each of loop until it remains 1, so it is 4. 4 and 5 is the correct answer. The following function represent with sorting. Look at this code. We can see that the bubble sort is used in two directions, forward and backward, until the array is sorted. So the correct answer is cocktail sort. Thank you for listening.